Hello, everybody, and welcome to General Geeks, the only video podcast that brings the inscrutable world of scientific jargon down to an understandable level. I'm your host, Raphael, and today's topic is tsunamis and tsunami mitigation. We have with us Kyle Wong, a hydrologist from the University of Toronto,
Hello, everyone.
as well as Jason Jiang, an oceanographer from Japan.
Hi, sir. It's good to be here.
So to start us off, I think a lot of people have this conception of a tsunami where it's just a big wave that kind of crashes over everything. How accurate is that? And are there any sort of nuances to how a tsunami works that we should discuss? Or is it literally just like a big wave?
Well, yeah, essentially a tsunami is a very tall wave that sweeps over the land, but what people didn't realize that the reason tsunamis are so devastating is because these waves are very, very tall. It might go up to 100 feet. So those waves are carrying a lot of gravitational potential energy due to their height. And then in the ocean, though, it- where waves starts out, they are actually much shorter, but they move much more quickly. It can be up to almost 1,000 kilometers per hour. So what happened is that these waves are carrying a lot of kinetic energy, and when they approach to the shore, they get shortened, and this kinetic energy is converted into gravitational potential energy.
Oh, it looks like our technical editor, Jeremy's brought up an image of this phenomenon. Yeah, you can really see the waves sort of get smooshed together as they reach the shore. So what I'm hearing is that tsunamis do more damage due to their height than due to how fast they're moving.
Right. So another aspect of how tsunamis do damage is that after they stop moving forwards, the force of gravity sucks all the water back out to the sea. And this can do additional damage, just like the waves we see on a beach, but now is on a much larger scale. It can also take breeze and people far out from the sea, where they are at the whim of the ocean currents.
So you talked about tsunamis initially forming with kinetic energy, right? Tsunamis form due to earthquakes, but I'm wondering is how do they get this initial kick of kinetic energy in the first place?
Earthquakes are what produce tsunamis. So there is this elastic potential energy in the Earth that is released as kinetic energy in the form of an earthquake. So that energy is what transferred to the water. Only specific sorts of earthquakes can produce tsunamis, though.
Well, what sort of earthquakes? Like, you mean they have to be underwater earthquakes, or are there other requirements?
Well, yeah, sort of, but it needs to be very high degree, typically 7.5 or greater on a Richter scale. Additionally, there are different earthquakes depending on how the tectonic plates move, and this affects if a tsunami will form. For example, a surge earthquake is a situation where one plate shifts over another, like this, and such kind is much more likely to form a tsunami than a strike slip. It's like sliding this way, sliding parallel to each other.
So I'm aware that earthquakes can't be predicted, like nobody knows where an earthquake will strike next. Is the same thing true for tsunamis, or is there a way of predicting when they'll happen?
Earthquake can't be predicted for sure, but early warning system using seismometers can alert areas of an incoming quake before they reach them. Similar techniques work for tsunamis as well. In the 20th century and early 21st century, countries around the Pacific Ring of Fire only developed their own tsunami prediction theorem. Uh, as example, Japan, it constructed seismometers at Sendai, the coast of Japan, and predicted tsunami intensity based on earthquake wave amplitude and distance near the Pacific fault. In 3 minutes, a tsunami warning will be disseminated to the local communities. Besides detecting earthquakes, US, Japan, and South American countries deploy tide gauges and commences to share data after the 2004 Indian Ocean tsunami. Those buoys measure wave movements and any abnormal surface waves. Wavelengths, height, and front depths are reported to every country for earthquake and tsunami assessment. Such data sets play an effective role in canceling false alarms and giving warnings in a great distance.
Wow, such a detailed answer. Since the warning only arrives at a short time before the tsunami hits, I imagine there's probably not much time for cities and communities to prepare for the effects of a tsunami. Is there anything specifically they do to mitigate these damaging effects?
The primary measure is to understand tsunami in a broad level and predict them as accurately as possible, which is the foundation. Tsunami damage can be minimized through education, communities, enhancing evacuation routes, and updating coastal building codes in the over the course of the time, of course. Other than these, improving models of human tsunami interactions, which are people's responses to disaster and tsunamis' damage on infrastructures. This helps prevent tsunamis damage after tsunami lands.
I see. So it's sort of a multifaceted approach.
Yeah,
How
for sure.
dangerous are tsunamis if all these techniques fail?
Well, if they all fail, tsunamis can take away lives easily and disrupt the society. When that high amount of water rush into the city, people may get trapped by water, and if they cannot find an appropriate shelter, also taking that the water waves are also rush away different heavy objects such as car and ships. When a person got trapped, he could easily get hit by those objects and injuries, and more seriously, deaths. Don't have a mindset that it will 100% safe if you can find a building and hide in it at any floor, even to the roof, since you are away from the wave. But it is wrong because if a building is not tsunami proof, it will have a chance to collapse. So if so it is quite dangerous to our lives, and tsunami can also cause a lot of different impacts as well.
So the old adage, like get to high ground, that's not really accurate if you're in a tsunami, huh?
Yeah.
Um, what do you mean by like different impacts? Like what else could be worse than all that?
Well, yeah, okay, so personal properties such as car and boats, jewelries and other luxuries may got washed away. Houses and different important roads and major buildings can be damaged by the tsunami waves as well. Economically, the cost needed to rebuild those infrastructure mentioned above could be a huge amount for the government. The flooding could force a stoppage of manufacturing and businesses, which hence affect both overseas and local tradings. Citizens are not able to work as well. Tourism is another major business that will fall by by the tsunami because some countries may rely on profit brought by the tourism, and that tsunami can cause a huge impact on those countries.
I see. So what about sort of like the long game, the long-term impacts? Are there any specifics you can share with us?
Yeah, of course. The disaster can also cause problems such as public health. Tsunamis can bring disease to the land, which may cause another pandemic in the country. Pollution is another long-term impact. The pollution here I mean is not only referring to the pollution brought by human, but now is the pollution by the tsunami. The water brought by the tsunami could wash a lot of waste and other pollutants, and when those water rush into any water treatment plants, it could contaminate the treatment water, hence affect the availability of clean water to the society, and have to be monitored for a certain time period. Make sure it's clean and safe. The water wave could also bring back a lot of pollutants that we dump into the sea back to the land, such as plastic bags, polystyrene boxes, and cans from drinks. It can also take a very long time to clean up that.
So to end off our program, I wanted to discuss the tsunami that occurred in Japan in 2011, the Tohoku earthquake and tsunami. This was a category, it was over a 9 on the Richter scale, this earthquake. And I'm wondering, how did this situation play out in Japan?
When the 2011 event occurred, based on the promptly estimated magnitude, Japan Meteorological Agency issued a major tsunami warning to the coast with tide height estimation of 3 meters, 6 meters, and 3 meters, respectively. After tsunami was observed at offshore, JME revised the contents of the warning with estimates of 3 meters to over 10 meters. Receiving the tsunami warning, some residents claim that they don't feel they are going to evacuate because they are hiding after like over 10-meter seawall, so there's no possibility of water coming through. However, they are wrong. Even worse, in several communities, the radio or the speaker and like the communication system is down because of the blackout caused by the earthquakes. After prediction and people's response, how damaging is this, Kyle?
Okay, so the earthquake and tsunami caused the total death of around 15,900 in total. On the economic side, it has caused a direct damage of 235 billion US dollar during the whole events. And the tsunami also caused the explosion of the Fukushima Daiichi nuclear power station, where it had the contribution of 4,546 milliwatts of power to the city. This caused the radiation reactants to leak in Japan, and people all over the country were scared by that. And it also have impact by the radiation from like even now.
Oh, wow. It looks like Jeremy's brought up another image. This is the nuclear power station. Look at all the smoke billowing out of it. That's crazy. Wow. All
Yeah,
right.
it is.
Well, that is our time. It was great having both of you on the program.
Yeah, glad to be here.
It's a pleasure.
This was General Geeks, and be sure to stay tuned for next week's topic, radon and its place in the household.